And another concept here is the idea of creating hearing aids without batteries, because the ambient sound would create enough current to generate the electricity to run it. And anyone who's had people with hearing aids know they're constantly changing the batteries because they wear out. Laser suturing is another area of regenerative medicine that I found quite fascinating. The current way that a cut is healed is needle and thread. We sew it together and then we wait for the wound to heal and we remove the thread, or the thread dissolves. They found that by using a common ophthalmic liquid called rose bengal, you can actually put that on two sides of a cut in surgery and add the laser light, but not the heat, and it forces the collagen in the cells to grow together, thus reducing the scarring that can occur. The implications here for facial and other surgery is phenomenal. So what you get is a clean sealing. It is useful for nerve, eye, and blood vessel surgery. It's still in clinical trials, but I think this one will come out pretty quickly. It is limited to minor depth cuts, because when you're doing very deep cuts, the light cannot penetrate. Bone cuts cannot be used for this. Cellular fusion is a new dimension also, in which microfluidic chips are paired with stem cells. And I think this is fascinating, that to take a mechanical device and to merge it with a cell and fuse them together is to create a new hybrid of cell, which can then be used to reprogram other cells. And this has the potential of taking embryonic adult stem cells, which are not as controversial, and turning them into embryonic cells by forcing them to degenerate by this hybridization. We are also using electron beam melting to create patient-specific craniofacial titanium implants. This is our latest issue, our Society for Manufacturing Engineering magazine. And they had a wonderful issue on medical manufacturing. It is designed to create prostheses from CT scans, scaffolds that can be actually put in surgery on the brain, on the mandibles, creating artificial, very nano-level technologies at the very cell-specific level to reconstruct different parts of the body, and using custom-based titanium implants. And as you know, titanium is one of the lightest and strongest metals out there. So to be able to build the scaffold is quite fascinating, and to control it with mechanical properties. So our definition of nanotechnology goes beyond just that which may exist, but that which is controlled. BioMEMS is available and has been available, but it's now being applied toward surgical tools. BioMEMS stands for microelectromechanical systems. And we are now able to combine these tools with sensors. Up until now, we have been we've been using BioMEMS mostly for sensors, but now we're able to add surgical tools for this. So within a fraction of size, we'll be able to create surgical tools that can do open heart surgery without stopping the heartbeat in the heart itself. Just a tiny incision into the side of the heart, pop in the surgery. It will do both the sensing to determine the pressure, thus eliminating the need for catheterization in pre-heart surgery, and also performing the surgery itself. So, I'm turning it over to my illustrious.
Along the same lines, with Ray Kurzweil's law of accelerating